So hello everyone, welcome to SNS4SNS 2026. We're very happy to be starting this event with OpenOP, the latest SDG under the ecosystem of ETSI. I'm Dimitris Gogos, chair of the technical committee of OpenOP and part of Intracom Telecom, which is committed to heavily contribute to this project. And today, together with my colleagues Cesar, Sergio and Julio, we'll be giving you an introduction and a tutorial on OpenOP. This is the agenda of today's session. We will start with the background motivation behind OpenOP. Then we will have an overview of the current status. We will walk through the OpenOP architecture. And then we'll look at the upcoming release 1, the release roadmap, and we'll continue with the tutorials. Let's start with the background and motivation behind OpenOP. OpenOP was conceived by an R&D community which is balanced between industry and academia. The goal was to take innovative and ambitious EU research and turn it into something practical and usable. OpenOP builds upon the flagship EU research project, Sunrise 6G, which tries to build a pan-European 6G federation infrastructure. By leveraging developer-friendly Camara APIs and GSMA Federation Manager APIs, we're trying to build a network of networks. OpenOP does not only target the telecom experts, but rather tries to facilitate vertical application stakeholders like providers or developers on how to easily access the telecom ecosystem. The aim is to create impact to a wider community of developers, practitioners, and researchers. OpenOP started in July 2025, and since then we have attended multiple key events. We started with 8 founding members, and currently we are 23 members and keep on growing. We have created strong links with large R&D projects. We have been recognized by the SNSJU as one of its top 10 key achievements for 2025, and we're also proudly co-organizing today's event. So what is OpenOP? OpenOP is an open source operator platform which was designed to provide seamless network federation. To do that, we offer a unified federated framework for operators, developers, and service providers. The platform is aligned with GSMA requirements for interoperator federation. It supports developer-friendly standardized Camara APIs. It integrates with a broad range of southbound platforms like Kubernetes or 3GPP network exposure functions, and it exposes AI and ML capabilities in order to support more advanced use cases. The goal is to create a neutral playground where telecom operators, vendors, SMEs, and research institutions can all come together in order to innovate and collaborate. Now, let's have an overview on the current status. Release 0 was delivered in September 2025, and the team there has established solid foundations for the evolution of OpenOP. We're exposing Camara APIs that translate into cloud-native Kubernetes and 5G core solutions. We have implemented a network federation manager, which is aligned with the GSMA OPG east-west bound interface specifications, and we have set CI/CD pipelines in our code base for software packaging and software deployment. We have established release processes with cycles of every 6 months, and the initial architecture is in place. However, this is a work in progress, always with the aim for a modular and extensible platform. So let's walk through the current OpenOP architecture. At the very top, we have the consumer, which could be an application provider or an application developer or an enterprise customer, and he interacts with our platform using standardized Camara APIs. The entry point for our platform is the Open Exposure Gateway, which, as the name suggests, it exposes the different APIs that we are supporting. Once a request comes to the Open Exposure Gateway, it gets validated. We apply security policies like authentication and authorization, and then it gets routed to the next component, which is the Service Resource Manager. The Service Resource Manager is the brains behind OpenOP. as it is the entity that knows how to translate a request towards specific service and network resources. Once the request comes to the SRM, then it starts to plan the orchestration in order for the end-to-end result to be achieved. To do that, it uses transformation functions, which are adapters that take the technology-agnostic requests and turns it into technology-specific southbound actions towards the telco cloud, where there we could have infrastructure platforms like Kubernetes or network components like network exposure functions. Another important component is the Federation Manager. This allows cross-operator communication via standardized interfaces from GSMA. And this is what allows developers to be able to use resources from another operator, but always at the same time, the operator is in control of his own network. So looking forward to the upcoming Release 1. Release 1 is targeted for this month, February 2026. And the aim for the release is to increase the ease of use of the platform and streamline the overall developer experience. To do that, we are introducing features like the developer portal for vertical application providers, where we're building an intuitive GUI for users to be able to interact with the different functionalities of OpenOP. We are introducing a first version of integration with AI, where we'll be exposing an MCP server and delivering an AI agent that will allow developers to control the platform using natural language prompts. With the new Helm-based deployment configuration, we streamline the overall developer experience, and now developers can get started quite quickly in their local setups by deploying the full platform using Helm charts on top of kind clusters. And finally, we are expanding the Camara API support by introducing the new device location API. Another important milestone is that for the first time, we have validated interoperability between OpenOP and the Open Exposure NEF for the Camara Quality on Demand API, which is what Julio will be showing later on today during the session. This slide summarizes the release calendar. As I mentioned, we have releases every 6 months. So release 1 is due this month, February 2026. It will be followed by release 2 in September 2026, and then release 3 and 4 in February and September 2027. Of course, that doesn't exclude optional minor releases in between, depending on the software development progress and the contributions. So for example, we could have a release 1.5 in the second quarter of 2026, or release 2.5 in the fourth quarter of 2026. The release roadmap is under definition. However, so far, the goal was that release 0 and release 1 will provide a robust foundation for the platform, where we'll have the core components in place. Then that would take us to release 2, where we would focus on integrating with more southbound technologies and enhancing the automation capabilities of the platform. In release 3, we would bring a broader community interoperability. And then in the longer term, for release 4, we would define the goals based on the evolution of the requirements and the contributions. So that concludes my introduction for OpenOP, and now I will give the floor to Cesar and Sergio to start the tutorial on the Federation Manager.
Okay, thank you, Dimitris. Well, now we are going to present a demonstration about two useful modules that we have in the OpenOP platform, which is the Federation Manager and the Transformation Functions SDK. So as the agenda for today, we have first the motivation and scope. And after this, we will see the Open Operator Platform Architecture Overview, the Federation Manager, Transformation Functions SDK, and we will have a demonstration end-to-end with the different kind of flow deployments and with conclusions. So the telco cloud the telco infras and 6G technologies now requires interoperable, federated, and experimental infrastructures. And due to the downside of this, right now we have current testbeds that are heterogeneous and are fragmented. So we need this integration across domain, which is complex and is not following the proper standards. And we offer a robust east-westbound interface defined by GSMA OPG, which is essential to enable inter-operator federation, to avoid siloed solutions, and to support scalable cross-domain orchestration and monetization. So we present the SDK, which aims to simplify the federation and enable standardized APIs and the federation manager. So this is an overview of the architecture of Open Operator Platform. This has evolved from the Sunrise 6G project, and we can see two parts here. The first one is the operator A, or called the originating OP, and we have the operator B, which is the partner OP. So as Dimitris was explaining before, the architecture, we have an entry point, which is the Open Exposure Gateway, in which we have all the Camara services APIs that will communicate either to the service resource manager in order to deploy different applications on use of the network domain. And we have another flow, which is the federation flow, which follows the east-westbound interface standards. So we have two roles here, mainly, which is or two novelties, which is the Open SDK, which is is a library, is a Python library, is a modular design and developer friendly, which allows the translation of these Camara payloads into the southbound interface technologies payloads. We support three different domains, which are the Edge Cloud domain, the network domain, and ORAN domain. And as well, we have the federation flow, which uses the federation manager application, which is under the standard of GSMA. We will see this in a depth way later. So the first element is the federation manager. Here, as I was saying, is in charge of not only the process of federating different infrastructures, but as well the lifecycle management of applications. So this enables the federation establishment, the subscription to availability zones, sharing the artifacts, onboarding the application, and lifecycle management of these ones. As well, we have a source code, which is open source, and we have here the different links to access it, to clone it. We have different readmes and all documentation there in order to quickly deploy this. So going on with the transformation function SDK, this is like an overview architecture of how it works, how it connects the different modules within the framework. And as I was saying, it supports three domains, the Edge Cloud domain, network, and ORAN. And is a modular design, making it easier for anyone to contribute with this or adapt their own technology solutions to this framework, and translates the Camara and GSMA calls to underlying technologies. So in the Edge Cloud transformation functions, we support Camara, Edge Application Management API. We support GSMA, east-westbound interface federation manager API. And this enable the onboarding of application instances and all the lifecycle management of this. We have 3 different technologies right now to showcase, which and are integrated in the SDK, which are the I2H, the Aeros, and Kubernetes. For the network transformation functions, we support Camara QD, location retrieval, and traffic influence APIs. We abstract 3GPP NF API across 3 different technologies, which are the Open5GS, OpenAir interface, and Open5G core. As well, we enable QoS session management, traffic steering, and location retrieval. And this provides an unified developer experience across network vendors. And as well, we support the ORAN transformation functions, which are the unified ORAN adapter, which is a single interface for underlying rigs. We have XApp and RApp management. We have as well rig discovery, and all of this is vendor agnostic. Also, we have the source code right here of the Open SDK, which we can download, we can try it, and we can create an environment here in order to test. So going with the flows of the demos that we will showcase right here, the first flow is as follows. We're going to deploy an application, a demo application, using the intra domain. So the entry point will be the Open Exposure Gateway. We will provide different payloads in order to onboard an application and after to deploy an instance of this. It will be using the Open SDK with the Edge Cloud adapter, which in this case is the Light to Edge, which is one of the solutions that we have. And we will see the flow right here. So as you can see, this is the whole Open Operator platform deployed, showcasing all of the modules that we have. This one is the Open Exposure Gateway API that supports application onboarding and application deployment, the lifecycle management. We can have the different availability zones, the quality on demand functions, traffic influence functions, and federation management for the federation establishment. Also, we can show right here the Service Resource Manager Controller API and all of the functions and that it has. And our Edge Cloud solution, which is Light to Edge. So app onboarding, so we can try right here and check that nothing is deployed yet. The same in the instances are not deployed, and we will showcase here. So let's do. First of all, we need to onboard. We go to apps. And we pass different information, the image path, what kind of repo is, if it's public, private, and some specifications. We got it there. And also we can check in our Edge solution if now we have something deployed here. Now it's showing the onboarding. And with the ID, we can do the instantiation of this. Okay. To make sure of this, we can even go to check the edge cloud zones and see what availability zone we have right now. And it shows that we are using the light to edge infra. So we execute. And now we have deployed the application. We can check it here as well. Deployment. And there we have our application. And also we have as well the one of the services that we have also connected right now, and probably we can just show you how it's interacting with our NEF in our premises in I2CAT. We can create a session, a quality on demand session, and we can then retrieve it and remove it. So we have our session created. Now we retrieve the session, and as well we can delete it. Okay. So we have showed right here, we have done this this flow and also this one, connecting to the service resource manager, to the network domain, and targeting our NEF and core. And the next demo will be the federation establishment, which is going to be explained by my colleague Sergio right here.
As I was saying, what I will be showing now, it's a bit of a more, it's a similar workflow, but a bit more complex because why we are implying here another operator. Okay, so what we see here, it's like the use case. It's okay. I'm an operator and I have my infra available, but I also want to partner with some other operator and deploy some application in his infrastructure. Okay, so this process involves like two steps. One is the federation establishment, and then the next step is the deployment of the application. Okay, we will see these two workflows. The deployment of the application is very similar to the local deployment that Cesar showed, but we also need to do first the federation establishment. So let's go through it. So again, so the nice thing about that is that the entry point is only the Open Exposure Gateway. So we will do everything through this module here. Okay. So the idea is that this module is like a very user friendly and so developers can easily use it. Yeah. Again, we will be using again, the same operator platform that we have in our premises. Let's open the OEG. Okay. So we are in the same status where Cesar left us. So if we check the edge cloud zones, now we will see that we only have one. Okay, we only have like if we are operator A, we only see our operator A's zones. Okay, and now what we want to do is like we want to add an extra zone that it's not in our premises to deploy an application. So let's do that. So first thing we need to do is to create a federation, and this involves two steps. I will guide you through it. First step is called the /partner endpoint, which I have the payload here. Okay, so let's go through it. So we need to send to our partner operator. We need to tell like some name, the country code, the mobile network codes, some date, and some credentials. Okay, and so we will send these credentials to the other operator, and he will authenticate us. And based on who we are, he will respond us with, okay, you are operator A, and you have these zones for you to use. Okay, so let's see that. Great, so the federation succeeded. Okay, so the other operator said, okay, this is the federation context ID. This is very important, okay, because this is the identifier of the federation. Okay, maybe just a technical comment here, but the federation is unidirectional. Okay, so it has direction. So now we have federation from operator A to operator B. Okay, so if we would like to have operator B to operator A, that will be a new federation. Okay, so we have this context ID that identifies this federation. And then the other operator, based on who we are, he said, okay, operator A, you can use these zones. Okay, and they have these characteristics, and this is the ID. And well, some extra parameters like the country code, the name, and the operator codes, and so on. Okay, so now let's say we have finished the authentication phase, but now we need to tell the operator, okay, I want to use this zone that you told me that I can use. So we need to use this /zones, okay? And for this, we need the context ID, sorry. Okay, and this is a very simple payload. We just say, okay, I want to use the ID of the zone. And I also provide a link, okay? The idea of this link, right now it is a placeholder because this is not yet implemented, but the idea is that the other operator can, so I send this subscription to a zone, okay, and I will tell the other operator, okay, I will be using your phone, your zone, and then let's see if something breaks or the zone has new capabilities like GPU, the other operator will notify me through this callback link that I provided to him, okay. So let's subscribe to the zone. Okay, so now we subscribe to the zone, and the other operator, he accepted it, and he tell, okay, so you can use this zone, and those are the resource quota limits that you have. Again, for now, those are placeholders, but the idea is that you have limited resources of that zone. You only support some flavors, and yeah, so that's it. Okay, so now we have completed, let's say, the federation. So if we go to check our zones, we should see exactly. So before we only had this one, but now we also have a new zone, okay, which is the operator zone that we just federated with. And this is very nice, but because I think it makes life from the operators or the verticals like very easy, because in the end you will see that deploying an application in another zone, it's the same workflow. That at this point it's a very similar workflow that Cesar just showed. So in fact, what we could do, it's like we could use the application that he onboarded. I think he onboarded a default, like a dummy Nginx application. So we could use that. So let's deploy it. Here's the payload. Okay, so before submitting this, let me show you, because the idea again of all of this is that the OpenOP Schedule Gateway makes life of the developers easy. So in fact, when we click the app instance, okay, let's deploy this application. In fact, what the OEG does, let me show you again a slide that, yeah. So we already did the federation establishment, we already did the subscription to the zones, and then these three operations, they will be done just in one operation. They will be aggregated in one operation of the OEG. So when we click okay, deploy this application, the OEG will tell the federation manager, okay, share this artifact, onboard this application in the other operator, and deploy the application. So yeah, let's see. So since those are like three endpoints, it will take a few seconds. So it's making like 3 calls. It's copying the artifact and everything. Okay, so now we have the application deployment, and well, I can show you also. I have here so those are the Kubernetes class. So the 2 operator platforms. Okay, so we have the operator platforms on top of Kubernetes. This is the operator A. Okay, and this is the operator B. Okay, so we check the operator B, we'll focus a bit. So we should see here so this Nginx application deployed like 26 seconds ago. So this is the application that we just deployed, okay? We check the logs, it's working, it's just an Nginx web server, okay? And yeah, now what we can do, it's like to delete the application, okay? And you will see like how easy it is to, if we go back to, how easy it is just since I have the rights to manage this edge cloud zone, I can delete an application from here and it will delete from here. Okay. So let's try to do that. Let's get the ID first. App instance ID, yeah, this one. Yeah, so that should delete the application. It didn't. Wait. Did I copy it right? Sorry, I copied the wrong ID, I think. Okay, I'm messing up with something, but that's the demo effect. So wait. Yeah, I was copying the wrong, I think. Yeah, okay, terminating. You see that the application deployed and now. So we just deleted the application that we just deployed. Okay, just with in our operator platform infrastructure. So yeah, that's basically it. So maybe I can close our demo. So the federation manager enables multi-operator federation plus the artifact application lifecycle management that we just show. Transformation functions translate the easy, friendly Camara APIs. I can make this. Sorry. Yeah, so transformation functions translate the Camara API calls into concrete SBI actions via pluggable adapters. And Camara APIs just provide a standardized and very easy to understand entry point. And the OP platform wraps these functionalities to enable interoperable, scalable, and vendor agnostic federated deployments. So yeah, that was it from our side, and I will give the floor to my colleague, Julio.
All right. Good morning, everybody. Well, thanks to my colleagues for showing us how it's easy to deploy an edge application using OpenOP across different domains and federated operators. What I would like to show you is what we can do with OpenOP to ensure that once this edge application is deployed, the users consuming these applications can actually take advantage of guaranteed QoS, of the experience deriving from the edge application itself. So the way Eurecom is supporting this is by providing the NEF and an underlying network infrastructure to validate and showcase this point. So I'm here as an engineer from Eurecom and as the NEF main contributor. So in the agenda today, I would like to introduce you to our project, which is OpenExposure, and especially to the NEF. I will show you how the NEF integrates with OpenOP and how the Camara API's QoD from OpenOP actually maps to the 3GPP APIs exposed by our solution. And I will conclude with a live QoD demo, in which I'll show you how this happened actually. So OpenExposure, it's an open source toolkit for network exposure that has been released by the NetSoft team at Eurecom, which I'm part of. It's under the Apache 2.0 license. So it's public and everybody's welcome to contribute. In the first release, we included 3 main components. So first thing first, the network exposure function, DNF. We are also providing a core network simulator, which supports 3GPP APIs exposure, and I'll show you why. I'll tell you why we decided to publish this component. And then we have vertical application examples deriving from research projects, collaborations with partners that, they are always useful for the community and to build new use cases. So our mission is to bridge the gap between the application providers and, of course, the vertical world and the telco world, which sometimes it's quite difficult to bridge. DNF, we are aiming for interoperability. We are testing our NEF against different open source core networks, and probably in the future also commercial ones. And interoperability, of course, it's important to simplify integration and experimentation. We are aiming also for rapid prototyping. That's why we're delivering this core network simulator. We want app developers to deploy this stack and to get ready to prototype and to build their applications on top of network capabilities. And of course, fuel open innovation. It's an open source project. We are collaborating with ETSI SDGs and many other open source projects. So this is a good thing to have for the community. So about DNF. It's an open source implementation of the release 18 standards from 3GPP. It has been tested, as I said, against OpenAir interface, core network, Open5GS, and Free5GC, sorry. And of course, it works as well with our network simulator. The scope of DNF, most of you, of course, know it, but the idea of NEF is to enable applications to consume network capabilities with some layer of abstraction. It's not 3GPP agnostic, but it's operator technology agnostic. So it means that we are abstracting the network capabilities and the technology of the operator in order for application to consume these APIs or capabilities more in general. So therefore, I would say that NEF is the key for interoperable network-aware applications that needs abstraction, that needs, of course, to let's say abstract some detailed information of the operator network. In the first release, we are shipping the NEF with those features. So as you can see, we are supporting many APIs. We have the traffic influence one, we have the monitoring event API, AS session with QS, UID address, and analytics exposure that comes from 3GPP technical specifications, but also we have some sidecar services for the community, for example, dataset exporter service, which might be useful for researchers or people that want to extract 3GPP events, datasets, control plane, user plane events, and so on. So how NEF is contributing to OpenOP and supporting OpenOP. So as I said before, NEF is providing a layer of abstraction of network capabilities, but it's still not enough because it's still 3GPP. It still uses 3GPP APIs, 3GPP interfaces, which are of course good, but for application and service developers, sometimes it might be too hard to interact with. And that's why OpenOP comes in help. They are providing an abstraction layer, a second abstraction layer that is based on Camera APIs, and then of course will simplify and will speed up the creation of new use cases for application developers. Of course, it's important to have those components well separated and isolated because, of course, we don't want complexity. NEF is also working with other SDGs, for example, OpenSlice, that is consuming NEF APIs. You will see tomorrow in the joint SDGs demo. We are a CAPIF provider as well. We are onboarding our APIs on OpenCAPIF in order to expose them via common API framework. And of course, we are collaborating with OpenOP to bridge the gap between OpenOP and the 5G network ecosystem. Speaking of the sub-band integration of the NEF, so everything that is underneath it, we tested it, as I said before, against different open source projects. Not all of them supports all the APIs that we do. That's why we created this simulator as well, is to support all the possible use cases. And of course, to create something more powerful in terms of sandbox and network testing. Just a few words on the core network simulator because it will come in help during our demo. It is able to simulate different VGP procedures. It generates user plane traffic. We have a Grafana dashboard to see real-time monitoring and statistics from the network. And we expose, of course, 3GPP APIs, for example, and services. For example, we have the AMF event exposure, SMF event exposure, and PCF APIs, which are exploited by the NEF. So, I mean, I think words spent on the NEF are enough. We can talk about demo and what we are going to show today. So, thanks to Etsy, we have a few VMs that have been allocated to us. In one of them, there is a running instance of OpenOP with the three components that you can see here. In the other one, we have the NEF together with the core simulator. And what we are going to do today is that the step after the deployment of an application when we want to request quality on demand for that application. So a consumer will interact with OpenOP. It will be me via Swagger. And OpenOP will translate the request to the NEF that we request it to the core network to establish a dedicated quality of service flow for the user consuming the application. So as I said before, we will be interacting with OpenOP using Swagger. You can see in the picture we have quality on demand functions and also traffic influence functions. First one are useful when we want to guarantee specific QoS for the user consuming the application. The second one is to really exploit the advantage of having edge applications, because sometimes the user traffic is routed in a default way in the 5G network, and it's not optimal for edge deployments. That's where traffic influence comes in help and allows us to influence the way traffic is routed within the network in order to offload it to the edge. Of course, Swagger is available at this address, and I will be showing you in a few seconds. We have more details about the OpenOP and NEF integration. So basically, OpenOP will be using the 3GPP session with QoS and the traffic influence APIs, respectively, for QoD and traffic influence. Then the NEF will, of course, do some internal logic following 3GPP procedures, and then contact the core network via the 3GPP APIs. I will give you some details also of the demo scenario before going forward. So DOE has a throughput limitation imposed by the operators. It's something common. In this case, we are, of course, setting this limitation very low to 80 megabit per second, but it's just to show you the point. So the throughput and the capacity that the user has been allocated with is full. There is background traffic. The user has no more resources for consuming this edge application. But the edge application that we just deployed, it's bandwidth. It's bandwidth sensible. So we need bandwidth for this application. We need bitrate for this application. The way we can ensure that the user can go above the operator limits is by requesting a temporary QoD session via the OpenOP application. More detailed, more technical. So DOE has a default QoS flow, which is non-GBR, which is an MBR flow of 80 megabit per second in both uplink and downlink, so it's limited. we have background traffic, and the edge application requires something that has a guaranteed bandwidth, a guaranteed bitrate. So we enable this using the QD request from OpenOP. So to prepare the setup, we'll go fast on these slides, and then we will get to see how it actually works. We will clone the NEF manifest from the official repository. We will use the manifest that allows us to deploy the entire stack, NEF plus core simulator. We will check briefly the configuration files, and then we will deploy the full stack. We will also modify the core simulator profile. It's already, of course, there in the repo that I'm cloning, but just to show you, we can configure the network profile, PLMN, DNN, slice, and the default QS for the user, which it's what I told to you before. Then we deploy, and then we start the simulation using the SIM CLI. We will see through the Grafana dashboard of the core simulator how those policies that are created from OpenOP impacts the user behavior, the traffic behavior, and we will see it through the live statistics that are provided by the core network simulator. And during the setup, during the demo, we'll be also checking the logs so that you can see all the flow, how it goes through in the network. And we'll be looking at the NEF logs and the core simulator logs. So we'll get started and prepare the setup with you. All right, so on the right, you can see my browser page. It's already on the core network UI. The core network, the stack is not deployed yet, so there's nothing. On the left, the terminal, I will clone the repo, which is Open Exposure NEF deployment on the Eurecom GitLab. I already have it. I will remove. So once you clone the repo, you can see, you go inside deployment, and then you will see two different folders. The NEF compose, which allows you to deploy the standalone NEF, and the NEF core sim compose, which the NEF plus the core simulator. In this case, we'll be using the latter. So the NEF core sim. In the repo, you will find the Docker compose file in the folder and the config files. So the config files allow you to configure the different northbound services. And then, of course, we have some configuration about the core simulator that I showed you in the slides. So we will be looking at it really quickly. So this is the setup of the core network. This is the PLMN. We will be, sorry, the tutorial. So this is the configuration that we'll be using. We will use a default QS policy that will be enforced on the UI when the PDU session is established. So we can proceed by deploying everything. So you can see we are deploying all the different services here. We wait for the simulator to come up as well. All right. So I will do a Docker PS to show you that all the services are here. The northbound APIs are healthy, so we can start to consume them. I will put on the top the logs of the NEF API, so which is the GPP AS session with QS. As you can see in the API configuration, we have some mapping of QS profiles with the characteristic of the QS we want to enable. We will be enabling this one. It's the QSE, which is for video streaming, and it has a minimum bandwidth requirements in both downlink and uplink of 40 megabit per second. And here below, I will be first thing first start the simulation. So core simulator, CLI. So you can see from the status that it's just configured, and now I can start it. And now it's started. So I will take, I will take the logs with you. All right, so the simulation is started here. You can see we have exposed the 3GPP APIs that the NF will be consuming. And the UI is registered to the network and it has a PDU session. We can also see that we enabled a default QS flow on this PDU session. Maybe I will be switch this here. All right. So here, while the Grafana dashboard should be alive, yes, you can see it. So we are running traffic in the simulator in order to saturate all the available throughput, and it's around 73 megabit per second. So we are right below the operator limits, but it's not enough for our application. So what I will do here is to basically use the quality on demand functions in the Open Exposure Gateway Swagger here, as my colleagues already did before, but I will show you more details. So we'll start by creating a session. To create a session, we have to use this body that I will explain it to you. So first thing first, we have to specify the target device that will be influenced by this policy. And in this case, it will be our only user connected to the network. We have the address here in the dashboard, and it's 12.1.0.1. So just copied it here. Then we have to specify the application server. So the application IP is the IP of the application that has been deployed in the edge. In this case, for the simulator, it's this one. The QS profile that we want to enable for this traffic flow, so which is QSE, as I told you before, and then the duration of the policy. So as soon as I execute this policy, more throughput and more capacity will be allocated to the user, and we will see the traffic statistics increase. So now it should be we have an error from the OpenOP. Let's try it again. Okay, so again, demo effects. Something I think is wrong with the. I'm not really familiar with it. So I think we can. What we can do, Dimitris, if you agree, we can show the video, right? So I have prepared a video for you, of course. All right, so I guess you can see now the video on my screen. So it's something we went through already together. All right. So basically, yeah, I will be preparing the Swagger to send the quality on demand request. All right. So this is what I showed you also in the picture before. And then we can execute the call. And then you will see that the call has been accepted. The QS flow is requested. And of course, on the right in the traffic statistics, the total throughput of the UI has increased to around 110, 120 megabit per second, which is the total amount of the different QS flow. You can see in the simulator that the core network has received the policy request, what kind of policy we are going to activate, and that we enabled a new QS flow in the UI to support this QS requirement. What we can do, below you, of course, you see the PCF, the NEF logs. What we can do also is to, get the session that has been created and to check that the session is running. So use the session ID. And we see that the QS profile is available in the QS status. Sometimes it might not be the case if resources are not enough in the network to ensure it. And then, of course, you can delete. Once you delete, of course, the QS flow, you will see that the UE throughput will drop again to 80 megabit per second because we have no more dedicated QS flow for that UE. So you can see in the logs that now the policy has been deleted, and with the policy also the dedicated QS flow for that application. So this is what we managed to validate with our NEF. It works with the core network simulator, but the NEF has been tested for this API also with Open5JS. So we can say that Open5JS has been validated as well with OpenOP. We have also the traffic influence API that it's working in our setup, and I think we will be showing it in the cross SDG demo tomorrow. So this concludes my my demonstration, and I hope you enjoyed it. And if you have any questions, don't hesitate. Thank you.
So we are done with the tutorials and the session. One note is that we are quite new SDG, so we are open for collaboration. So whether you are a researcher or developer or an operator, please feel free to contact us if you want to contribute and collaborate. And if you have any questions around the session, we are free. Yep.
Hello, can you hear me? Okay, perfect. Thank you for the demo. Just a question, maybe I lost the part of it. How the operator A knows, let's say, the network information of operator B to communicate with it and have the federation?
I guess that question is for me, right? For the
Yes.
Yeah. Okay. Honestly, we haven't played with the, let's say, the federated case for the network. So we have been only working in that, make sure that we can deploy applications in the local, and that's what we show. And for the network, I believe like somehow the network information should be exposed to the SRM, to the SRM module, and the SRM module should also report this information back to the operator A. But yeah, but this is something that we will work on for the next release. Like
just as information, it's an IP, it's something of the underlying network. What information has to be, let's say, exposed to get the contact? It's a public IP. I mean, it's.
So you mean how the operator A knows about the network of operator B?
Yes.
So it is shared in the federation context. So when you establish a federation, you need to exchange somehow this information. But again, the details of this, like we will look into the next release.
Questions from anyone?
Yeah. These presentations will be uploaded, or they are available on some online resource?
We'll make sure to give you the link to download all the presentation from today, tomorrow, and even the conference part.
Okay, thank you. And what are the larger question? Very basic. So I'm not per se a software developer, more of a system design architect on the infrastructure architecture. So I think these are very interesting group of initiatives which are converging into a holistic framework. Do we have some kind of a framework diagram as of today? How do they plug into each other to give a holistic value to the ecosystem stakeholder? Different ecosystem stakeholders can identify where do I come in and from where I start, because it's a very complex framework. There are so many multiple stakeholders. There are application developers, there are users, and then there are within application, there are some common foundational application, and there are use case specific applications which have their own specific requirements on whether it is network slicing or security and all that. So I think, do we have some kind of a generic framework on these multiple initiatives, and how do they plug and play with each other to bring a holistic value to the ecosystem? Is there any work done on this thing? Because that is what I would, as system design architect, I would be more interested in that, to understand and put them together.
Is the question about OpenOP individually or how it collaborates with?
No, so see, when we are looking at OpenAP and whether all these initiatives are very good individual pieces of initiatives are converging to the larger ecosystem. And larger ecosystem is all 5G or 6G, 5G advanced or 6G or 7G infrastructure, which right from the users to the network operators, developers, and all that, infrastructure designers, everyone. So they are all ecosystem stakeholders from different perspectives. So if there is a holistic big picture where people can identify, okay, I belong here. So if I need to get into, where do I get into, and what are the aspects I get into, and then what I'll get as a ready, and this is where I can stop my own exploration.
So I think Sylvia can take this question.
Yes, this is a very good question. Actually, all these SDGs, all these software initiatives have been initiated as individual activities, but of course they all belong to the network. And actually we have a very interesting initiative going on where we're plugging all these components together. Tomorrow afternoon, after the coffee break, we'll have a 1.5 hour session where we're going to see how the different things can be integrated, what kind of use cases we can solve. And of course, this is work in progress with a very early stage, but it's going to be a long-term activity we have here at ETSI, making all the SDGs work together and build something together.
Great, thank you. I think that's where I would be personally interested in. Thank you.
I have also a question. Hello, I'm here. Okay, I'm George Karetsos from University of Thessaly. For the demo, I wanted to ask if you had real 5G cores behind for the federation, and what kind of cores did you have?
So we use the core simulator, but I believe the NEF supports the OAI and Open5GS.
So you didn't have any real 5G cores?
No, right now in the VM it's just the core simulator in the demo that you have just seen.
Okay, okay. Thank you.
Hello, thank you for the demo and for the presentations. What I would like to ask is whether once we have the federation, the application is instantiated just on the federated partner and not only on the home OP.
So you mean how it works, how one application gets in one operator or locally, how that works?
Yes, yes.
Okay.
I mean.
So I think, can I share the screen?
Yeah.
So, sorry, is that the question that you're trying to make?
Yes, I mean, once we have the federation, I understand that the app is instantiated on the partner OP, right?
So first you establish a federation.
Yes.
Okay, and then like you say you are operator A and you tell to operator B, okay, I want to federate with you. Operator B tells you, okay, you can deploy stuff in this zone. And then you say, okay, I take this zone, and then you subscribe to that zone. And at this point, you just see in the OEG, in the entry point, you just see this as another zone, okay? And then the OEG, when you tell, okay, I want to deploy in this zone, the OEG has an internal logic that he knows, okay, this zone belongs to me, or this zone belongs to a remote operator. And then the flow goes either to the right or down.
Okay, okay. So I missed the part that you specify the zone where the application will be deployed.
Yeah, so then you have some internal logic in the OEG that you say, okay, this zone belongs to me or this zone belongs to somewhere else. And then you forward everything to the federation manager and then.
Okay, and another question is, I think free 5GC is not supported right now as in the OOP. I mean, I think you said Open5GS, Open5G Core, and Open Air interface. But I see that it is supported with the Eurecoms through the Eurecoms NEF simulator. Yeah.
So basically, we do support Prefab-GC from the NEF. It hasn't been validated because we didn't have a use case in OpenOP during Sunrise. But I mean, it supports traffic inference, so it should work. But it's not been tested in the project.
Do you foresee the integration of Free5GC as an 5G core in the OpenOP?
This maybe it's more a question to Dimitri.
Yes, we are planning to integrate with more southbound technologies, more vendors as we go forwards, but there is not a concrete plan on the roadmap for that yet. So we will be a bit use case driven in that aspect.
Thank you.
May I as well to add? Actually, we have developed this Open SDK tool, which is open source and is available for everyone to want to contribute to add their own technologies, their own solutions with, let's say, just not pluggable, but easy to adapt to this library. So maybe if we are not covering some kind of solutions that is on demand, maybe some can see this opportunity to contribute with their own solutions, adding this code to the SDK, so we can have this connection between the Open Exposure Gateway to any other agnostic vendors in the southbound interface. So that's a chance as well to contribute with this.
Yep.
Yes, I take the chance to remind you that all these SDG communities participation is open to HC members and non-members. So you're very most welcome to join and bring your use cases, bring your components, and help shape the future of these software projects.
Any other questions?
Hi, this is Mika. Before the actual federation, how do I know the ecosystem? What are kind of discoverable for me?
You want to take?
I mean, so with the initial, when you start the federation, okay, you send the credentials to the other operator. So as far as I know, yeah, as far as I know, there is no, at least in the OP, for now, there is no discoverable mechanisms. So you must send the, okay, I want to authenticate with this operator, and I send the credentials and the secrets and so on. Yeah,
Yes. So just to also complement here, right now, the only source of discovering things is our Swagger API, where you can manually do requests and see what's there. But in the upcoming release, we plan to have a portal, very interactive admin dashboard, where it will be more easy for developers to have an overview of what's there and also how to interact with the system. And that's due this month, so it will be out very soon. Any other questions or comments? Otherwise, maybe we can conclude with this session. Okay.